Algebra 1 Lesson 89, we are looking at our quadratic functions and looking at the graph on our coordinate grid, especially looking at some of the characteristics. So some of the vocab words that we're going to be using is vertex of a parabola. This is the highest or lowest point of the parabola, and it's the turning point, meaning if we have a parabola that is going that is upside down, we are talking about that point where it stops increasing and it's now decreasing. Or if it's right side up, the point at which it's decreasing and then increasing. The minimum of a function is also the vertex, okay, and we'll have a minimum in this type of situation, but not this one. Whereas with a maximum of the function, the greatest point possible, this one will have a maximum, whereas this one will not. A zero of a function is where y cross it, or where our parabola crosses the x-axis. So let's say this is the x-axis here. We're looking for intercepts. Typically there are two. There could be just one, or it is possible that there will be zero. So we are looking for those x-intercepts, and we'll have a couple different names for them. Now to practice finding a vertex, remember this is the turning point, so we can say right here is that turning point at -4, 0. Oops, sorry. 0, -4. There we go. And the minimum is that vertex 0, -4. The maximum, in this case, because that parabola goes on forever, there is not a maximum. Okay, it goes on into infinity. Now, for the same reason, what is the domain? All of our x values can be included here when we're talking about the domain because that parabola continues forever. So we can use a compound inequality to write this, to say we are going from -infinity to, includes x to +infinity. So x is greater than -infinity and x is less than infinity. We never want to use the less than or equal sign here because we can't be equal to infinity. And now the range. The range for y, we want to say, okay, the lowest point that we can get to is -4. Okay, so -4 is less than y, which is less than infinity, because that y can go all the way up to infinity. Let's try it again with now a upside down parabola, and we would say that the vertex is about right there at 2, 5. And what's the minimum? In this case, since it goes on forever, it would go on to -infinity, so there really is no minimum. The maximum in this case is at 2, 5. And the domain, just like the other one, since it can continue out and down forever and ever and ever, the domain is from -infinity to infinity. The other way that you could say that is all real numbers. And the range, we want to say, what is the lowest point? Well, the lowest point for the y's is -infinity, is less than y, which is less than or equal to 5. Okay, 5 is our highest point. And I should have included on this last side that, yes, we can be equal to -4, so we should have -4 is less than or equal to y, which is less than infinity. Okay. And one more try. Our vertex is at 0, 3. The minimum, we do not have one, but the maximum is at 0, 3. The domain is all real numbers. And the range, lowest point is -infinity, and it goes all the way up until 3. Okay? So, domain, range, and looking at that vertex. So, zeros of a function is the other part of a quadratic, and this is when y equals 0. We're looking for an intercept. We can call it a zero, we can call it a root. All of these names really just denote this x-intercept. Now in this parabola, we can see it crosses the x-axis right here at -1, 0 and at 3, 0. So those are my two intercepts. Now it's interesting to note that the factored form of this quadratic gives us those intercepts. Okay, so if we were to factor it, I would factor out a -1 first and get x squared minus 2x minus 3. And we could factor it again to say -1 times x minus 3 times x plus 1. Now, if you'll notice, if we were to set that equal to 0, the two options that we have is to get this first one equal to 0, which would mean 3 would be my option for x, or I would need to get this one equal to 0, which means that -1 would be my option for x. So we can find our x-intercepts using the factored form of our quadratic. That's in a whole other lesson, but just to give you a little bit of a preview of it. Now, once again, we can look at our zeros. And we would say here we just have one zero at -2, 0. You can find that using the factored form of the quadratic. And once again, we have two x-intercepts right here at -4, 0 and at 2, 0. So we have those two x-intercepts, those two roots, those two zeros. We can call them all of those different names. Once again, we have one intercept here at 1, 0. And in the second one, we have no zeros. There are no x-intercepts. All right, it does not cross the x-axis, which means if we were to try to factor that one, and we would get, factor out a -1, and we get x squared plus 1, there is no x value here that would make that equal, that expression equal to 0. So we say there are no real roots. Now, all of this leads up to our ability to graph some of these quadratics, and another part that we need is the axis of symmetry, which is a line that divides the figure into two mirror images, and it passes through the vertex, which if we look at this axis of symmetry, the red line on the parabola, we see that it crosses right through this vertex at 2, -1. And we can see that on the right side of it and the left side, it's exactly the same. When we look at our x-intercepts, though, they correlate to that vertex and that axis of symmetry at x equals 2. Remember, vertical lines we describe as x equals. And we notice that that axis of symmetry is right between our two intercepts. We can actually average them and say, all right, the x values here, 1 plus 3, I average them and find that x equals 2. So if we know our two x-intercepts, I can just say that the vertex, that axis of symmetry that goes right through it, is right in between them. Okay, so if we know where our two intercepts are, we can find the axis of symmetry. Now, if there's just one x-intercept, like in this case, -4.5, 0, we would say that's also the vertex of this parabola, so I would make my axis of symmetry right there. And so my equation for that is -4.5. Okay, and for another one, all right, we would say my axis of symmetry is x equals 4, goes right through that vertex. This one on the right side is a little bit harder to see, but we can average my two x's. So -3 plus 5 divided by 2 is 2 over 2, or just 1. So my axis of symmetry, oops, sorry about that. All right, my axis of symmetry here is just at x equals 1. All right, and same for this bottom one. I'm going to average my x's, so -1.5 plus 8 divided by 2. So that's 6.5, so that's 3.25. My axis of symmetry here is at x equals 3.25. Always using an equation to describe an axis of symmetry, since it is this imaginary line that cuts it in half. Now, if we don't have those two x-intercepts, we can use this formula. And we use it based on our general formula for a quadratic, so ax squared plus bx plus c. And we plug in those numbers for x equals -b over 2a. And so if we have a quadratic, x squared plus 6x plus 5, we can say a is 1, okay, 1x squared, b is 6, and c is 5. We don't actually use that c value in this formula, but we can use a and b to plug it in to say, all right, x is going to equal -b, okay, so -6 over 2 times a, so 2 times 1. And we can simplify to say my axis of symmetry is going to be at -3. And if we were to put it on a graph, we could see, yes, that is the line that cuts through our parabola, okay? And once again, let's try it. And here we have a of -2, b of 3, c of -1. So we plug it in and say x is equal to -b over 2 times a. So we get x is -3 over -4, so x is just 3/4. Now that is where it's going to cut through that parabola. Now we use this axis of symmetry not only to say that's where my vertex is, but if we have this parabola, we can say that is the x value of my parabola. Okay, and it actually is like this time. Okay, so this is the x value. I have 3/4 as my x value, but I'm missing my y value. So our next step here is to use the axis of symmetry in order to find the vertex of my parabola. So let's try that. And for this one, we have an a value of -1, a b value of -4. And we plug those in to say negative b, so we have a -4 over 2 times -1. Okay, so these give us a +4 over -2, so we get x equals -2 as my axis of symmetry. Now that is the x value of my vertex. So we have -2 comma something as my vertex. Well, just like any equation, I can plug that x value back into the equation in order to find the y value. So we say y is equal to x squared, so -2 squared, minus 4 times -2 plus 3. And we just need to simplify. So y is equal to -2 squared is a +4, and then we have the negative outside, so we have -4. And a -4 times -2 is a +8 plus 3. So y is equal to -4 plus 8 is a +4 plus 3 is 7. So we see that our vertex is actually at -2 comma 7. That is our vertex. Okay, and once again, we can do it with this second one. Our axis of symmetry is going to be -b over 2a. So we say -5 over 6, and we could plug that in to find our y value. So we're going to say y is equal to 3 times x squared, so -5 over 6 squared, plus 5 times -5 over 6. And we'll have some simplifying to do for sure with that one. So we're going to square this and say y is equal to 3 times 25 over 36 plus -25 over 6. And we'll get some common denominators here. We'll say y is equal to 75 over 36 plus, let's see, 25 times 6 is -150 over 36. I just multiplied this by 6 over 6. All right, so we add those together and we get y is equal to -75 over 36, I believe, if I simplified correctly. So we would say my vertex is at -5 over 6. That's my x value that I get from here. And I plugged it back in to find my y value at -75 over 36. Okay? All right. So we can use these quadratics as well to solve problems like this. A golf ball is hit from an elevated platform 10 feet above the ground. It starts with a vertical speed of 160 feet per second. Ignoring friction, the equation is y equals -16t squared plus 160t plus 10. It gives the height y as a function of time. Find the highest point the ball reaches and how long it takes to reach it, which means we need to find the vertex of this function. So we're going to use -b over 2a. All right, so we say x, or in this case t, equals -b, which is -160, over 2a, so -16, equals, so we have -160 over a -32, which I believe simplifies just to be 5. Okay, so we see that the x value in this equation is just 5, or our time 5, okay, that we can replace t with in our original equation. And when we do that, we will find how far or how high it is at that highest point after that 5 seconds. And you can try that on your own. And here is another one that you can try as well to find the vertex. Well, I hope this is helpful for your homework and for studying.